Hello everybody, we're getting ready to do lesson 9.3 of Algebra 2 Math. This will be part 1. If you need any course materials, email me here. 9.3, evaluate trigonometric functions of any angle. We got a 34-point skill sheet available for this, and then we have an 8-point note-taking guide that's also available for this. Teachers, here's your bell work. Find one positive angle, one negative angle. It's coterminal with these angle measures here. Give your students 3-4 minutes for this. Okay, welcome back. Your solutions for your bell work. There is number 1, 615 would be coterminal, and then negative 105 would be coterminal. So we add and subtract 360 to that. And then up here, 2 pi is 360, so we add and subtract that, we get 5 pi over 6, and then 19 pi over 6 for that. Okay, evaluate trigonometric functions of any angle. You evaluated trig functions of an acute angle. You will evaluate trig functions of any angle. So, general definitions of trig functions. Let theta be an angle in standard position, and let xy be the point where the terminal side of theta intersects the circle of x squared plus y squared equals r squared. The 6 trigonometric functions of theta are defined as follows. So here is our unit circle here. Here is xy there. Sine theta would be y over r. Cosecant theta would be r over y, so it would be the inverse of sine would be cosecant. So r would be r over our y would be here. So it would be this dimension over our y coordinate there. And then cosine would be x over r. X would be our x coordinate here over r. So r plays a big role here. And then secant would be the inverse of our cosine, would be r over x. And then our tan would be y over x, so it would be our y over our x would be our tan. Then our cotan, guess what, would be our inverse of our tan, x over y. These are sometimes called circular functions. So evaluate trig functions given a point. So we got a point here, negative 4, 3, on the terminal side of an angle theta. This is our angle theta here in standard position. Evaluate 6 trig functions of theta. Use Pythagorean theorem to find r. We got to find the value of r here, which we do using a Pythagorean theorem. And then using negative 4y equals 3 and r equals 5, you can write the following. So here's our trig functions. 3 over 5 for sine, cosine is negative 4 over 5, tan is negative 3 over 4, y over x, so this would be your y over our x here. We found these dimensions here, remember. And then our cosecant would be r over y, 5 over 3, our secant would be negative 5 over 4, and then our cotan would be negative 4 over 3. And that's all from our dimensions here of this triangle formed by our r and our drawing a perpendicular up to our point. Okay, let's do one now. Guided practice. Students, this one's on you. Down here, evaluate the 6 trig functions for this situation right here. There's your point. We're going to do this one down here. Practice. So evaluate the 6 trig functions. Here's our point here on our unit circle. Here's theta. X equals 3, y equals negative 3. That's right here. So our trig functions, we find our r value was 3 times the square root of 2. So our sine would be y over r. So we negative 3 over 3 times square root 2. We rationalize our denominator by multiplying. First canceling out our 3's here. We get -1 over square root of 2. Then we rationalize our denominator by multiplying denominator and our numerator by square root of 2. You should know that by now. And then cosine theta x over r, because this situation here, and then we rationalize our denominator, we get this number here for cosine. Tan would be -3 over 3, be negative. And then our cosecant, which is the inverse of our sine function, will be negative square root of 2. And then our secant, which would be an inverse of our cosine function, would be the square root of 2. Then our cotan would be the inverse of our tan function. Okay, the unit circle. The circle x squared plus y squared equals 1. Here's our unit circle. Center 0, 0 is called a unit circle. The values of sine and cosine are simply y and x coordinate, respectively, at the point where the terminal side of theta intersects the unit circle. Here's theta here, so where it intersects is out here. And then we come up with our trig again. Okay, here we have our axis here. It is convenient to use the unit circle to find trig functions of quadrantal angles. A quadrantal angle is an angle in standard position whose terminal side lies on the x-axis. The measure of a quadrantal angle is always the multiple of 90 degrees, or pi over 2 radians. So here is pi over 2. Here is pi. And then this is 3/2 pi here. And then this would be 2 pi there. Quadrantal angles. So our next example here, example 2, use a unit circle to evaluate 6 trig functions. Theta equals 270. Here's theta here. 270 lies on our this y-axis here. The terminal side of theta intersects unit circle at 0, -1. So use 0, x equals 0, y equals -1 to evaluate the trig functions. So here would be our sine theta, cosine theta, tan theta is undefined, cosecant theta would be -1, secant theta would be undefined, and then our cotan would be 0 for this angle here, theta. Okay, our guided practice. Students use the unit circle to evaluate 6 trig functions of theta equals 180. We're going to do this in our guided practice here. So evaluate 6 trig functions of theta here. So we end up over here at -5, -12. So now x equals -5, y equals -12. So to find our r, we plug in our values that we know. We come up with 13 for our radius. So now we can do our trig functions now that we know all of their measurements of our triangle. Tan is 5, and then cosecant is -13 over 12. Secant is -13 over 5. And then cotan will be 5 over 12. So again, this is what we're looking at here for this situation here. Okay, that is part 1 of 9.3. If you need more, part 2, part 3, email me here. If you need worksheets, email me. You need notation guides, email me.